So you might have cells that prefer spots of red or spots of green with those single opponent receptive fields. Then with the double opponent, you might have cells that prefer a spot of green surrounded by red or a spot of red surrounded by green. But what you don't actually have, right? So like, you know, that's just red versus greenness. So you don't have cells that prefer a spot of red surrounded by blue or a spot of green surrounded by blue or vice versa, right? And that's what this is kind of roughly illustrating, is that basically there's this color opponent pathway where some cells are basically excited by green but inhibited by red, again, or vice versa, right? So you've got this kind of like red-green pathway. And that's one of the sort of kind of like systems in the brain for kind of analyzing color, right, is based on red-green contrast. Now, again, you do need to use that info in your blue cones or your short wavelength cones. So the weird thing here, and I kind of talked about this a little bit last time, but just to recap it, the weird thing with the blue pathway is it's not individually contrasted with either the red cones or the green cones. If you remember, you know, that diagram I showed last time, the red and the green cones actually have a pretty similar range of wavelengths that they respond to versus the blue cones that are a little bit different. So I guess the nervous system during the course of evolution decided like it was not worth having a separate blue versus red or blue versus green pathway. So instead, you have basically a neural pathway that like at a stage we're not going to worry about, at an earlier stage of processing, kind of combines input from red and green cones, right? So you kind of have cells sort of early on that essentially just like take input from both red and green cones in a given spatial location and sort of combine them together. And if you remember, when you combine red and green light, you essentially perceive yellow, right? So essentially what we call this is like, you have these sort of cells that are like excited by yellow light, which really means they're excited by either red or green light, right? But the thing that contains both red and green light is yellow light, so we call it like yellow sensitive cells, right? So once you combine the red and green responses, then you can kind of have similar, a similar pathway to the red-green pathway where you contrast this yellow cell's output against the output from blue cones, right, or short wavelength cones, and essentially you get a pathway that is sensitive to blue versus yellow contrast, right? And then, you know, I don't have pictures of this, but you would have then cells in your retina and your LGN that have receptor fields similar to the previous slide, where they might prefer blue light in the center, or well, just spots of blue light or just spots of yellow light, or blue surrounded by yellow or yellow surrounded by blue, when we're talking about the double opponent pathways, right? So it's a similar idea to the red versus green contrast, but you have this kind of intermediate neural step where the red and the green cone input gets combined, and then that is contrasted against the blue cone input. And again, I'm not too concerned myself about where exactly this all gets wired up in the nervous system. If you are, that is something you can pursue on your own time, because I don't frankly remember exactly how that works. But the basic idea is you kind of have two ways that these three cones get processed together, right? Which is that your red gets compared to your green, and your blue gets compared to the combination of your red and your green. And that gives you kind of like two color pathways based on red versus green contrast and blue versus yellow contrast, right? And if you remember back to that LAB color space I described last time, which I don't have up, but I can bring up that example again in Photoshop. If you remember that LAB color space, that's what this color space is defined based on, right? So here, let me pull up the color picker. So, you know, if I put my lightness slider up here, right? I've got this kind of, if you can see this, I've got this kind of square of color, right? So you can think of the way your visual system kind of describes color in terms of like, one of your systems forms kind of the x-axis of this square, and one of your systems forms the y-axis. So like, essentially you've got your kind of yellower tones up here, your bluer tones down here, right? So this b-axis of the LAB color space corresponds to like the blue-yellow contrast that we get, right? And then the x-axis here, or really the a-axis of this LAB color space, has greener on the left and redder on the right. So you can think of like, you know, this x-axis of this picture reflecting the output of those like red versus green sensitive cells, right? So essentially what this is saying, right, is that you can kind of describe any color in this rectangle here for the square as a combination of how much your red versus green contrast system is active, and in terms of how, your red versus green contrast system is active, and how much your blue versus yellow contrast system is active, right? So like,